For this demonstration, I'm going to explain how to perform calibration of an ultrasonic tester when you have either an unknown material or you don't have a step block available. So in this case, you only have a single known distance on a part that you have. So we're going to use the Sonatest wave ultrasonic flaw detector. And for a probe, I'm using, and this is an Olympus probe, it's a model V112-10/0.25. It's a 1/4 inch diameter, 10 megahertz direct contact transducer. And the aluminum block this is just a scrap piece of aluminum that I have, but it does have one dimension, this taller part on the left is shown at the tall section, or on the image of this on the right, it's the bottom portion is exactly, it is 3 inches pretty much dead on across the face. And so we're going to be placing the probe on the face shown here by the arrows and using that to be able to calibrate our probe based on only having a single 3-inch known dimension. And then at the end, I can show some of these. Once we've calibrated our probe, we can see where these different holes are kind of in this other section. So if I bring up the display screen from our wave tester, for this one, just like my previous videos, I'm going to go with the 3655 class configuration menu. And I'm going to go with the default configuration. So I'm going to start with default and I'm going to launch it. And I'm going to do kind of a quick setup here. If you want more detail on this, I would recommend watching the video I did on setup and calibration using a 5-step block where I go into this in detail. But I'm going to leave my velocity off a ways so that we can see how this works again. Normally aluminum, we would preset it to about 0.2500 or 0.2490. But by starting at 0.270, it gives me a little bit of room to kind of explain the calibration process. Probe 0 will start at 0 microseconds. We'll change that after we've got the velocity set. The range, this block is 3 inches tall, and what we're going to use is a backwall echo and then a secondary backwall echo to do it. So the backwall echo is at 3 inches exactly. A secondary echo is going to be twice that, so 6 inches. So I'm going to adjust this to be a little bit over that. I'm going to go to 6.5 inches here. So we have across the bottom of the screen, we can see 0 to 6.5 inches. We're using a standard probe, so I'm not going to set anything for delay. The angle is 0 as well. Frequency, I'm going to set this to a 10 megahertz probe. Our probe width is 1/4 inch. We're in pulse echo mode. Pulse echo mode. I'm going to leave the envelope off for right now, and I'm not going to worry about editing the part because this is for, we're not going to be using the scan plan layout. My signal is full rectified. I'm going to leave the filters off. What I am going to do is turn on a gate, however. I'm going to turn the gate on. I'm going to start my gate at about 2.5 inches. And I'm going to make my gate about 4 inches wide. So that will cover the 3-inch as well as the 6-inch, the 3-inch backwall echo as well as the 6-inch secondary echo. My gate level, I'm going to bring down to 70%. Again, that doesn't really matter where you want to set it, but that's where it is. Okay. I'm going to leave, and then the alarm, I mean, we can turn that on. It automatically enables it when you create the gate. And I'm not going to make any changes to my display from the default here. So back to me. So I'm going to, first, I'm probably going to have to set my gain. We can see this is a much taller block. Actually, I'm going to change my range to 7 inches so that it shows up. This is a much taller block. And so I want to get a signal that goes. The larger the material, the higher the gain, right? It's going to take more energy, and you gotta turn up the probe listening ability to see a weaker signal because the signal is being attenuated more as it travels through the block. So I need to bring my gain up, and I want to get that primary echo, the one that should be about 3 inches, which is up to about the 80% height. So you can see we got to put it at about 40. And depending on how hard I press on the probe, we get a difference there. But pretty consistent. We're getting 80% full screen height with about 40 decibels. Maybe even, I could even go up to say 50, see where that puts us. Maybe too high. Let's try 45. There, now I don't have to push the probe quite so hard. And we'll stick with 40. Okay, so 40 decibels on gain there. Okay. Now we need to start calibrating our velocity. So the difference between the front wall echo, or sorry, the back wall echo, and a secondary back wall echo should be exactly 3 inches. Right now, our primary echo is 3.242 inches, our primary back wall echo. In order to be able to check one at a time, I'm going to make my gate smaller so that what I can do is shift it. So right now, I have it over the main back wall, the primary back wall echo. If I drive this gate to the right, you can see even though the peak isn't touching it, that's not going to trigger an alarm, but it is going to tell me what that peak is there. So it's saying 6.465. And we want to get these exactly 3 inches apart. So if I bring up the calculator, we can see we're at 6.488 at the secondary echo. And I bring this back to the primary echo. So I take 6.488 minus 3.243. And that tells me it's giving me a distance of 3.245 inches. And remember, this is supposed to be exactly 3 inches. So it's almost a quarter of an inch off between the two. So I need to adjust my frequency in order to bring that down. So I'm going to go into my main screen here. I'm going to adjust, my velocity. The frequency we're going to leave because it's a 10 megahertz probe. And I'm going to start bringing my velocity down. I'm going to bring it down to 0.2600. Okay, and now let's see where we're at. Clear my calculator. I'm going to start with the further one. So I'm at 6.225 minus our closer peak, 3.122. Now you can see we're at a difference of 103,000. So it's closer, definitely much closer than the almost quarter-inch difference before. But we're still not right at that 3. We want those two peaks to be 3 inches exactly. So I'm going to adjust my velocity again. And I'll bring it down. I'll bring it down to 0.255. Okay. So if I set it at 0.255, I go over the small peak, I've got 6.106. And then I subtract the large peak, 3.062. And now you can see we're down to 44,000, so we're getting closer, but we're still not quite there yet. So we need to adjust our velocity some more. So I'm going to bring it down. I'm going to use the standard aluminum velocity I have here, 0.249. We'll give that a try. So we were at 44 thousandths there. So let's go to our further peak. Okay, our far peak, our secondary echo. Uh-oh, we may have gone too far. Secondary echo is now 5.961. If we subtract our closer one, we're at 2.990. And we've actually gone too far. So what that means is I got to turn my velocity back up again. So let's try 0.2500. We'll start a round number again and see where we end up. Okay. So my far peak, 5.985. 5.985 minus my near peak, 3.002. Oh, we're still not there, but we're closer. We've got to turn our velocity up a little bit more. And now I can start dialing it in using this. So I'm going to bring it up 0.02 of an inch per microsecond. And here we're at 6.060. Me pushing down on it did change that. So we're at, let's get a better bond here. I think there we go. So there we go. We're at 34. If I bring this over, 34 thousandths off there. 26. So we're getting closer. That's so that is 6.034 minus 3.026. Oh, we're 8 thousandths off, but we still need to, now we need to bring it down just a hair. So going back to my velocity, let's bring it down to 17. So we're at 6.027, 6.022. That's still, we still need to go a little bit down a little bit to move everything left. So 6.01, 6.030, or there we go, 6.009, 3.014. Oh, we're too far again. So sometimes dialing this in does take, we got to go up to bring it back the other direction. We get a better bond going here. There we go. Oh, it isn't on my screen. Here we go. 6.030, 3.015. We got to come up a little bit. That's what I get for 3.019, 3.021. Now we're only 2 thousandths off. 21 thousandths, 23. We're about 2 thousandths off, so keep going up. 6.026, 6.021. Okay, I'm going to go down one. And so now I'm at 6.023, 3.020. So I'm within 2 to 3 thousandths of each other. So our velocity, the current velocity in this material is 0.2516 inches per microsecond. Now we need to adjust our probe zero, but at this point we don't need that secondary echo anymore. So I'm going to go ahead and change my range. And remember, this block's only 3 inches thick. So I'm going to go to 3.5 inches. Okay. What's that? I can drag my gate over, kind of up out of the way. We don't need it from there. Okay. Actually, we do need it. Excuse me. So I'm going to put my gate over this. You can see we're at 3.021. So now I'm going to hit probe 0. And I'm going to start increasing that until my gate tells me that that echo is right at 3 inches exactly, because our block is 3 inches exactly. So it takes 0.165 microseconds for that pulse to get from the transducer, the piezoelectric transducer inside my probe to the surface of my work of the piece I'm testing. So now our transducer and our velocity are matched to the material we have. Even though we don't know what kind of aluminum it was and we didn't have different steps, we use that secondary echo, that secondary backwall echo, as a second step. Now I can put this on different parts of the block. So I'm going to turn my block and I can see if I can find flaws. So on this side, let's measure, first of all, I'm going to measure the long side of the block. It's 3.173 inches. And if I start to move it around, you'll see different little peaks showing up here. And these are the several holes. When I first showed that block, we had several holes. And so that's what I'm seeing right now. I'm placing my probe on what is the bottom surface here, the surface closest to the ruler. And as I move it around, I can see holes that are further away. That big echo is the backwall echo, and there's the far holes. And here I've got closer holes. So if I turn on my memory, my peak memory, here is my backwall, the overall width of the part. Okay. And here, some of these other ones are the different holes And I'm picking up a couple of them at a time because they're too close together to see. So you can see as I move this left and right, I can cause those different holes to show up. You know, those five or six echoes that are occurring between the 2 and 3 inch range. And if I go further right, I can actually find the spot where there's a corner cut out. So I got a new backwall echo there. So it's move this over, it's 1.538 inches from top to bottom. And the area I'm looking at here, so where I've been putting my probe is I've been putting my probe along this edge right down here. And so the six little peaks that I got, not five, excuse me, 5 peaks I got were these right here. And then when I got a distance, the distance I have right now, which is the 1.532, the distance of 1.532 that I'm getting is right here. My probe is on this point right here, and I'm sending sound at 1.532 inches to this surface right here. So that shows how even with a part, even though I don't have a calibration piece for this part, I am able to calibrate my probe to it, and I'm able to make measurements on it to determine where those holes are and where that step is.